Gentlemen, a very good day to all. So now, gents, I would like us to continue with intersecting functions, part 2. So now this would be with regards to the hyperbola function. So that's the hyperbola function over there, as well as the linear function. So now both these two sketches, or rather functions, would intersect at point A and point B. So now I would like to just highlight how to go about finding or determining points A and B. So now that would be the gist of this very lesson. So now I also want to highlight on how to find the lengths. So that would be specific lengths on the graph itself. So now these lengths would be stemming from the origin. So now remember that the coordinates of the origin would just be 0 is to 0 over there. So now D, or point D, would be the x-intercept of the hyperbola. So that would be that point D over there. Point C would then be the y-intercept of the hyperbola. So now remember that to get your x and y intercept, you have to let your y to equal 0 and also your x to equal 0. So that would be respectively. Once you've done so, you can then just subtract from the origin, which would always just be 0, and you should get a positive value for the distance. So that would be the distance between O and C. So this in itself, so let's say we had solved for the y, so that would be for the y-intercept, and we found the y-intercept to be, let's say we found it to be 2. So that would be the y value there. And we'd also gone and found the x-intercept to be 1. So now if we had to have done that, then to find OC, which would be this distance here, that would be OC from the origin, which is 0, all the way up to C. So now this in itself would just be 2 units. So now that in itself would just be 2 units, since you would be subtracting from 0. So you can also do the same thing for the distance OD, which would also just be 1 unit. So that would be just the 1 unit. So that's that distance over there. So now that in itself was finding the distance. Just to go back with respect to intersecting functions, or rather where the functions themselves intersect. So now you can see clearly that both these functions would intersect at point A as well as point B. So now to get the equation, or rather to get the points themselves, you would need to equate the two functions. So that would be, you would need to equate the hyperbola to the linear, and you would essentially be solving a quadratic. So that in itself would be of the form ax squared plus bx plus c. So that's actually equal to 0 over there. So now once you get to this far, you would essentially either factorize or use the quadratic formula in order to solve for x. So now this would be the x for point A, as well as point B. To get the corresponding y values, you would use any of the two equations, either the parabola or rather either the hyperbola or the linear, in order to get the corresponding y value. So now that's what I wanted to just quickly share with you before we go into today's example. So I'm going to just flip on over to the next page so that we are able to get through the example. So now the diagram below shows the graph of f of x. So that in itself is the hyperbola, and the g of x, which would just be linear. So now that in itself is the graph over there. 1.1 wants us to calculate the length of OA. So now let's see where OA is. We have located O, so I'm going to just maybe use a different color on this. So that's the origin over there, O, and then A would be the x-intercept of the hyperbola. So now remember that to get your x-intercept, you would need to let the y to equal 0. So let's just move on over to the next page so that we may find point A first. So that is 1.1. We know we are given f of x equals 1 divided by x plus 1. I think that should be the function over there. So now to find the x-intercept, we would need to let the f of x to equal 0 and then solve for x. So we can then do so by, so that's -1, moving the +1 to the left-hand side. 1 divided by x. We can then just cross multiply to give us a -x equals 1. Therefore, x would equal -1. So now that in itself would be the x value of point A. So now just going backwards, since the origin only has 0:0 as the coordinate, you can essentially just say that the length of OA would essentially just be 1 unit, which is just the positive version of the x coordinate. So that in itself would just be 1 unit. So now let's move on over to the second question, which wants us to determine the coordinates of B and C, which happen to be the points of intersection. So now remember that to find the points of intersection, you have to equate. So let me just move on to this page here. So that would be 1.2. To find the points of intersection, you have to equate the f of x function to the g of x function. So now the f of x function would be 1 divided by x plus 1, which equals -2x plus 4. So that would be the g of x function. So we can then just simplify this a bit further by moving the +1 to the right-hand side to give us a -2x plus 3. We can then just cross multiply. So cross multiplying would give us a -2x squared plus 3x, and then this would be equal to 1. So now to simplify further, we would then have a 3x there minus 1, which equals 0. We will multiply throughout by the negative. Once we do so, we would get the 2x squared minus 3x plus 1 equals 0. We can then factorize this as, so that would be 2x there, and x. We would also just have a 1 and a 1, and they would both be negative. And these the two brackets would again just be equal to 0. So we would have then found x. So the x in the first bracket would only give you a half. So that would be positive a half over there. Or the x would also just give you 1. So now once you found the x values, you can then make use of any of the two functions to find your corresponding y value. So I'm going to just maybe use a red marker on this. So that would be g of a half would equal a -2 a half plus 4. So now remember that this would be making use of the g of x function, the linear function. So now this would just be a -1 plus 4, which equals 3. So we can also do the same thing with the g of x again. So that's g of 1, which equals -2, 1 plus 4, and this is just equal to 2. So we can then say that the point, so we would have the half is to 3, as well as the 1 is to 2. So now we can then just maybe go back just to make sure we know which is which. So that would be 1 is 2. So let me just go back. So this should be C. So this should be C over there. And that should be B. So that would be B over there, or maybe let me just write it here. So that would be 1 is to 2, and this is half is to 3 over there. So now that would be how you determine the coordinates of the points of intersection of the two graphs. Gents, thank you once more for coming through. Please do have a good look at the vid before attempting the questions that do follow. A good day to all.